Hi, everyone. I'm Will Brown. I'm a research lead at Prime Intellect. And today I want to talk about RL environments, especially RL environments for language models, as I think a lot of people here are probably interested in language models. And I think RL has also been like a big theme in 2025 research. I think especially like post like deep research and O1 and R1 and all of these things, like a lot of people are really excited about it. And we've seen kind of a lot of the open source community kind of rally around reinforcement learning as this like theme. But I think there's also been this kind of parallel discourse around RL environments, especially in the context of the big labs, and people kind of wondering like talking about how one of the like scaling regimes that is like up next and that large labs have been taking advantage of is creating custom environments for LLMs that are capturing tasks of interest and training on lots of these such that models can then generalize. And I think in some ways this is like the analog of data, and we have had ecosystems in the past around data and understanding like how to build infrastructure around consuming data for language models. And this talk will largely be about kind of some thoughts and work I've been doing around the environments ecosystem and what does an ecosystem for open environments look like? What are the design considerations? How does this tie into the broader open source community? What are the challenges? What are the research questions, especially in the context of long horizon LLM agents? And so the open source AI in the RL era has a number of like different considerations that we are kind of thinking about and talking about. There's lots of scientific questions of like, is the way that we've been doing things the way we should keep doing them? Which algorithms do we use? What infrastructure do we have to build? What are the challenges here? As well as like, who's the user of this? What are the applications? What are the opportunities? Because I think like a lot of people here are like both very interested in the core science, in the open source code and the infrastructure and the research, but also like this stuff touches applications at different layers of the stack. And so I think especially as the tent grows bigger and as more people start becoming interested in these things, there's a number of different users of these that are not necessarily just machine learning engineers and researchers, but are people who are more focused on the application layer. And I think RL environments are a really interesting example where we have an opportunity to kind of design interfaces and abstractions that are, on one hand, needing to integrate quite closely with the tensors, with the GPUs, with the hardware, the infrastructure. On the other end, these are things that are kind of much closer to applications because they're mirroring some real world problem where we want the model to be able to do a thing that will eventually get deployed in some real world use case where there's an end user who's going to be interacting with it. And I think there's a lot of like opportunity to really discuss and like brainstorm and collaborate and in the open figure out what this community will look like, what this kind of effort will look like. And I think that a lot of this talk will be kind of different angles of this problem and how we've been thinking about it. And so there's some design considerations for agentic RL that I think are quite related to algorithmic choices. So we've already heard in the panel earlier people talk about this async versus sync divide between which sorts of RL algorithms you want to use. And I think there's kind of like these, you kind of have a rock and a hard place situation of you want to bite the bullet of going off policy and dealing with numerical instability issues, or do you want kind of fully synchronous, fully deterministic, like matching numerically rollouts with the cost of dealing with kind of heterogeneity in the completion time of these things if you're staying fully on policy. We've kind of taken the approach of saying, we're going to deal with the instabilities, we're going to do research around them. We believe there has to be a way, and that there's been a lot of great research that some that I'll talk about here, as well as from the broader community in figuring out how to keep like slightly off policy RL stable at scale. As well as how to kind of activate and grow community feedback loops. So like the open source community is not just about software you can use, but it's also about software that people are contributing to. And so what does it look like for people to contribute to this? How do you make it useful and incentive aligned for people to contribute to this so that the like pool of open environments, the ecosystem around open environments is something that is not just like people are doing for fun, but is something that is also very useful to people and something that allows things to become positive sum greater than the sum of their parts for the ecosystem at large, which I think is like very near and dear to the heart of a lot of people who have been working on open source AI infrastructure to date. And I think there's some cool new angles in the agent era that will both have to touch like the hardware as well as the applications. And then finally, just kind of how this fits into our broader mission. So we like the term open superintelligence stack as to what we see like everyone is kind of collectively building towards, which is just the idea that we want AI to be a thing that people have access to, that people are able to do what they want with, can customize and fine tune and deploy in different situations. And that we think that the way that you do this that makes it accessible to people is by kind of opening it up and sharing the research, sharing the tools, not just the end model checkpoints, but the code that's used to do this as well. And that's kind of what our mission is very driven by. And so our stack concretely at Prime Intellect, we train large models. We are kind of currently training our large-scale mixture of experts models that will be released in the coming months. We also maintain and create open source RL libraries. So the two that we'll touch on today are Prime RL, which is our kind of large-scale RL training stack, as well as Verifiers, which is kind of my project I started at the start of this year, which is all about creating an ecosystem and a library for creating RL environments and evals. This integrates with the Environments Hub, which is our platform around RL environments and creating and sharing them and deploying them, as well as Prime Intellect is kind of our origins are as a compute platform. So we have compute pooled from data centers all over the world that you can use compute, but also I think we're building towards the direction of kind of full stack research platform, which is kind of what the Environments Hub is a piece of, and also kind of one of our motivations for really trying to grow this community is to think about how do you create the tools that people actually will use at the end of the day to deploy agents and train agents in a variety of settings. And so for async RL, at the start of the year, we were really interested in scaling up RL. We were also really interested in doing it in the multi-data center regime, partly for scale reasons, like training on thousands of GPUs, but also that if you can do multi-data center training, it unlocks some really interesting things for fault tolerance and economics in that if you think of compute not as oh, I have 10,000 GPUs in a cluster, but rather I want to be able to operate on whatever compute I can get my hands on in the first place, where maybe I'll have my trainer on one medium-sized cluster, but if your RL is bottlenecked by inference is much more amenable to distributing it at scale, which means you can do things like take advantage of spot instance pricing or use heterogeneous hardware, or have a much more there's an easy way to do fault tolerance if you can do the multi-data center regime, which is just that workers are workers. If a worker dies, the whole pool is not necessarily tangled together. It's kind of okay if one drops out because you just need your rollouts to finish eventually. And so we did a lot of experiments validating that kind of recipes from the literature can be reproduced at scale in the asynchronous regime, where it's not that you want to go all the way off policy. You still want relatively fresh rollouts, relatively fresh data. But if you can just go a few steps off policy, this buys you a lot of flexibility in not needing all your rollouts to finish at the same time, in being able to synchronize your weights across longer distances or across slower bandwidths. And so this, if you kind of accept the goal, I think we now have the Scale RL paper from last week, I believe, that kind of really shows that up to 8 steps you can do this quite well at scale. And I think this is kind of the range where a lot of things become unlocked, which is that you can start doing things with much longer rollouts without needing your kind of absolute step time to be as much as a bottleneck. And this is also super amenable for handling slow communication. If this is if you have GPUs that are not co-located. And beyond this, we also have been building our the stack and doing more experience around how do you actually do this. And so concretely, this looks as opposed to just doing training, then rollouts, then training, then rollouts, we are having our training go in parallel to rollouts running from older policy copies on other GPUs. And if you have really fast communications, you can just do this one-step delay, which still has the bottleneck of the kind of long rollout problem. But if you can go a couple steps off policy, now you can have kind of both. You can have different copies of your models at the same time, and you can take advantage of this extra delay to have more time to do your broadcasts. So an extra one step of delay means that you are kind of only bottlenecked by how long it takes to send your weights around the world or across the country. And this generally is much more, you have a lot more slack to work with in terms of designing algorithms and taking advantage of hardware while still keeping efficiency very high. And so Prime RL is a trainer that we released that is built for this kind of fully disaggregated regime where you can have your inference workers just essentially be inference workers, and their job is to just update your weights when you tell them to as soon as they have a fresh copy. And the benefits of this is that you can kind of out of the box get multi-cluster support as well as heterogeneous hardware, because you're just disaggregating essentially generic inference workers. And then especially for things like if you're doing LoRa, or if you're in regimes where you're doing small models, this makes it much more practical to just kind of you're sending some files, you're sending some data, then the inference workers update as they can with whatever system you have locally. And this allows you to kind of have a pool of as recent as you want or as recent as you can have actors generating your rollouts. And we also kind of are very big fans of like the research literature and following like best practices that come out. And so I think like one of the big themes of some of our favorite papers of the year have been about doing things like kind of in-flight weight updates, ARIL, pipeline RL, scale RL, kind of all validating these efforts and showing that you kind of, if you kind of set everything up right, you do have a lot of flexibility in going a bit off policy, and you can do this without compromising efficiency, as well as lots of great research into kind of the numerical issues that come up, because we were seeing this a lot too in parallel to a lot of this work, which is that like in these long runs at a certain scale, you do start, the off policiness does start to compound, but correcting for this at the log prob level and using the right precision for the right parameters allows you to kind of get away with this. And you can kind of get away with, by adopting all these kind of like tips and tricks, going a bit off policy and having it still work without kind of your run crashing. Also, like Torch Titan has been a big inspiration for us in terms of like, especially as we kind of move towards MOEs more as our focus, expert parallelism has become much more essential, and like borrowing pieces from Torch Titan has been like a very kind of key piece of this. And so Intellect 3 is our model we're training right now, which is like large scale application of this whole stack, which is ongoing, but we'll have some more info to share on that soon. But if we want to train agent models, like we have the infrastructure is great, but what are we training them on? What's the task? What are the environments? And I think there's been this theme you hear a lot throughout the year of like people getting annoyed of all these papers just training like small Quen models on GSM8K or the math data set. And it's like, we actually need better environments. We need better tasks to train these models on. We need things that we actually mirror what the real world applications look like. And I think this has kind of been a big focus of ours in terms of trying to create tooling around environments as well as evals. And I think the evals ecosystem is actually a really interesting inspiration point where like people talk a lot about like, okay, what is an RL environment? And at the end of the day, many of them are essentially just evals. And I think we can use this as an opportunity to revisit the ecosystem around agentic evals, things like terminal bench, tau bench, sui bench, whatnot, and say, okay, what does it look like to unify these? How do you have, what would the right like interfaces be to be able to express these standard evals all kind of in the same language? And this is also a way to have a starting point for building an environment ecosystem, because if these things are essentially the same ideas of creating a little game with some tasks, with some interaction protocols, with some scoring that gives you some score that you could then use as a offline eval. An eval is essentially a first step of an RL run. And you want to do many of these, but the infrastructure for these things, it can be largely the same. And so Verifiers is the library that we've kind of created to be our SDK for creating environments as well as evals. And one of the design choices we made pretty early on that I think has been really helpful is prioritizing OpenAI compatibility as a key primitive here. Part of this is about just that it makes it easier once you have this in place, but also if you want lots of environments, if you want like environments for lots of different use cases, environments that mirror real world applications, you want the code for the environment to look pretty similar to the code for the applications themselves, and you want the people who are building those applications and working with those agents directly to be able to build environments. And so I think there's a lot of people who are building really cool agent applications who don't really care about chat templates or don't really care about tokenization. They just think about things in terms of API requests. And I think like that is the audience of people who really will be building lots of these environments. And so I think you want to create tools for people that are more accessible beyond just tensors, beyond just tokens, beyond just log probs, but be able to bridge the gap and be able to have an interface where on one end, the developer just thinks about essentially building an eval. On the other end, you think about reinforcement learning. And so Verifiers is this middle layer that allows you to kind of bridge this. And we found that this has been a really useful strategy for creating good open source community feedback loops and having this be a thing that is a fun educational tool for people that's actually useful for running their evals even if they don't care about RL. And so the Environments Hub is our platform built around this. And so now I kind of want to talk through Verifiers, the library, and some of the design choices we've made there in a bit more detail with some examples. So we released this in January, and it's had pretty great growth since. It was steady for a while, and then the Environments Hub, which we released about almost 2 months ago, really kickstarted a lot more adoption in people being really interested in doing this, partly because these things started to have a home that was not just a kind of overflowing repo, but it was like a place they could go, that they could browse, they could search, they could explore, and they could also do things with it. So we made it really easy to like run automatic evaluations on these, to look at the scores of other ones, to be able to like install them into your project. And so one idea here is that like each of these environments are kind of first-class Python projects that you can install as a dependency so that you can kind of take the ones you need without all the other ones needing to be kind of cluttering your code base. And the design goals concretely are that we are thinking about environments as a dual of evals, and that as we were kind of iterating on this, we would kind of look to the evals ecosystem and say, like, okay, can we port this one? If not, that's a problem. We need to add a feature or change something so that we can port this. And that's kind of been our kind of North Star, is that we want it to be really easy to take any implementation from some paper and translate it to this unified framework. And that has really been very informative for us in terms of learning what features people need, learning what people want to do with these things, because there actually are a lot of environments out there. They just exist as papers. And these papers have their own code bases. And a lot of times this is like research code that some poor student was writing like the night before deadline or before the final run was able to start. And it's not necessarily designed for maintainability or for composability, but the ideas are there. And so I think we do have a lot we can pull from. And so kind of this meta project we've been doing is really about trying to like find all the best papers, find all the best like benchmarks that exist in different incompatible forms and work on standardizing them and have the Environments Hub be a platform through which we can kind of have these implementations live and validate against the reference scores to ensure that like things are done correctly. And we also are like have taken a lot of inspiration from like traditional object-oriented programming. We think about abstractions a lot. We want things to be composable and extensible and reusable, because part of the what we are understanding here is that like we don't know all the answers yet. We don't know what people are going to want to do next year. Things will emerge, and we want to make sure that things can be both really useful as well as really flexible. And so we've tried to design like hierarchical abstractions in a way that have allowed, on one hand, like really easy entry points without baking these things in too much. And I'll give some examples shortly. But I think concretely we want to identify the patterns and then elevate these to features and have this be the feedback loop where we start understanding what people are doing with these things, what training tasks people want to do, what features are we missing, and then how do we add these. And so here's one example of a very simple environment that I think shows off some of our key abstractions. So we think parsing logic is both important in your rollouts as well as in your reward functions. And so we have a native object called a parser whose job is just to extract the piece of the thing you care about from the LLM. And so this can be something like find the boxed answer for a math question and pull this out. Reward functions are just functions. They take in different pieces of a rollout and return scores. And rubrics are these objects that are essentially our reward manager abstractions that allow you to kind of plug in your reward functions, tune your weights, and have these then plug into an environment. An environment is just a class that essentially has a data set and can have an eval data set. There's a few things like system prompts you can include if you want, but it's really about having an encapsulation for the pieces of data that you need, and also for managing lots of your kind of rollout infrastructure. So we're heavy on async IO. You could turn these things into endpoints if you want for like fast API, but the thing itself already has what it needs to be able to run it as like a single file without needing to be a separate server, but you could make it a separate server if you want. And the environment abstraction really is about the data comes in, a rollout function does something, then completions, trajectories, scores come out. And so multi-turn environment is kind of our abstraction for thinking about like the React patterns essentially. And it ended up being convenient to have single-turn environments be an instance of multi-turn environments because it's just one where you don't need to have an interaction protocol. There's no loop. There's just the while statement is always terminated after one step. But a lot of the logic for managing this can be contained in a single object. But you can also turn this into things that go higher up the stack. And so we think about like a lot of tasks people care about are essentially like agents with stateless tool calls. And so here we can extend multi-turn environment into a tool environment. And there's many types of tool environments you could do, but one is an MCP environment. So if you want MCP tools that are just like stateless endpoints, you can just have a wrapper where you plug in your MCP tools on one end, and it feels kind of like any of these agent frameworks you might have played with, but it's also natively pluggable into your RL stack. And so this is kind of our way of trying to build for the agent builders rather than just building for researchers. And that has been a very effective way to kind of like onboard people into the broader community, as well as just kind of like having a very simple and clean way to think about composing these stacks. As well as like some systems you need things that are much more complicated. And so like oftentimes these involve managing state at the rollout level. And so we've thought about like, especially for like tool call environments, a lot of times there is state that is tracking things like containers. So you might want to have a container that is your agent sandbox where your agent is going to be running and executing code, and maybe this code will also be used at the end to do your reward function. And so we think of this as like kind of a more complex version of an environment where in some cases you really want this. In some cases, if you're doing simple math questions, you kind of don't. And so I think this is our way of trying to strike a balance between like having really powerful abstractions as well as really user-friendly abstractions, which is just understanding the patterns people care about, having a stack that kind of has multiple entry points where you can do the really simple thing, as the hello world example, or you can start building up towards more realistic applications. And so here, this is one where we're essentially managing a Jupyter notebook for the agent on a per rollout basis, where this lives in, each rollout lives in its own container, and that can manage its own state. You could have the full file system, the full image, whatever you'd like. And ultimately, the kind of principle here that we're trying to strive for is that we want this to be easy, we want this to be fun, we want it to be educational, but we also want it to be useful. We want like the people who are doing RL are not just trying to like write a paper, like especially as the clusters get bigger and the funding gets higher. At some point, this does need to turn into applications. It needs to turn into things that are saving people time, that are making people money, that are allowing people to do things they previously couldn't. And we think that's kind of very important to keep in mind as we are kind of growing these tools and these ecosystems. Is like, what's the actual problem you care about at the end of the day? It's having an agent that you can deploy that is more cost effective or more better performing than the alternatives. And what should you be using to build these agents? How do you actually go from A to B? And we also think to do this in the open, it can't be one company, it can't be one startup, it can't be one platform. It needs to be a community. And so that's kind of why open source is very much at the heart of everything we do, is like, we know we're not going to do it all. We know that it's going to take the whole world kind of coming together and like figuring out these different parts of the problem, and then all talking about it and writing papers about it and sharing ideas with each other. And hopefully being able to build things that others can then build on top of. Because I think like the open source software that we already have is legacy from decades of people realizing new problems and contributing back to it. And we think that like, as we move from kind of RL as a research problem into RL as a thing that we care about people actually taking advantage of for like real world deployed products in the language model space outside of just the big labs, we're going to need communities of people that are really able to have their work built on top of each other and not have to reinvent the wheel each time, to not have everything end up just as a research repo in some paper, but be able to turn into a durable artifact that can then grow and be used in new applications. And so the Environments Hub is our home for these environments. It's also an evals platform. And so I think that's one entry point we found that's very effective for people to like ramp up, is just like, if you give people a platform where all the evals they care about are in one place and it's super easy to run them, this makes it a very useful thing to do that people want to contribute back to. If they make a new eval that they think people care about, rather than it being a new Git repo with its own custom runner for everything, it can live in a format with things next to it that are kind of interchangeable in the same sort of way. We are like, some examples are just like, we've had people like take textbooks and try to think about like, how do you take textbooks and convert them into RL environments. We've been doing lots of community programs around trying to give people like both structured like internships and residencies, as well as kind of one-off bounties to be able to grow the ecosystem of these environments. And we've had a really quickly growing community around people building on top of the stack that's been really exciting to see grow. As part of this, we're also like just kind of trying to grow this into a research platform that is more broadly useful. So some people don't care about RL, but they do care about evals. So we have evals. You can just use them as evals, even though the logic is built to also be RL compatible. We have Inference. If you want to just test these with API models, I think being able to test with an API model really lowers the barrier of friction for getting started. And so if you being able to do this on a laptop without connecting to a cluster makes it much faster to kind of get up and running starting from zero. And so that's one reason we like have really prioritized like building out Inference as an offering. Code sandboxes, like we have a compute platform, we might as well sell the ability to run your agents in the sandbox. And I think it's also, as we kind of move towards agents being used in more real world complex settings, being able to manage the environments with the platform makes it much easier to understand like how your resources are being used. But all of this is on top of an open source stack where you can kind of pick and choose what you want. If you don't want our sandboxes, you don't have to use them. You can kind of, the code's right there. You can use whatever orchestration platform you'd like, whatever compute you'd like to manage your manage your agent infrastructure. We have compute. And we also have really been trying to do this in partnership with the broader research community. And so the Verifiers library is intended to be trainer-agnostic. It's not just for Prime RL, it's for anybody who wants to use it. And the main thing we are telling people that is like the way you plug in is, if you can do an OpenAI endpoint, the rest is really easy. And I think a lot of RL frameworks have kind of done things in a way where it maybe is like super useful for debugging at like the token level, but tool calling gets annoying, chat templates get annoying. A lot of these things are nicely handled by abstractions that if you can do it once, you can then kind of repeat this, where if your inference endpoints are exposing this traditionally, like by default, as your way of interacting with this, you can get back your log probs and your token IDs from these requests anyways, and then it's the job of the environments to kind of pass these back to the trainer. And so we've integrated with Prime RL. We've also recently just pushed out a release with Think Machines for the Tinker library. We've integrated with TRL from Hugging Face, SkyRL from Berkeley, NemoRL, and others in the works that we're really excited about. And broadly speaking, our goal is to foster open research around RL and around RL environments. And so we've collected more than 400 implementations of unique environments today, including adaptations of many popular frameworks and evals. We have a bounty program for evals and re-implementing ideas from papers. We have an RL resident program where we've been bringing in like about a dozen researchers that we found from the broader community that have applied. We've had hundreds of people apply for these programs. And we're also committing $1 million in grants, more potentially to come with other partners that we've been discussing with, around kind of really scaling up the ability to sponsor people to go build these. We think that there's a lot of people who are doing research papers, who are grad students, who would love to do these things in a way where their research artifacts can then live on and be used by people. And that's part of what we're trying to grow with this ecosystem, is to make these things something that are not just about the paper, or not just about the idea, but about the ability to build on top of it, to use it, to have it be something that you can plug into a training run with lots of environments. And Intellect 3, our training run, is kind of taking a lot of environments from the Environments Hub and using them for our large-scale training. And so this is kind of what our North Star is, and what we're inspired by, and what we're hoping to accomplish with this. And the road ahead, as I just touched on, growing community, more integrations, more partnerships, proving this out at large scales for large models, as well as just dogfooding it ourselves. Like, our platform is what we use internally, and so we want both us to use it as well as other people as a feedback loop of understanding how we can be doing it better, as well as just nudging the world towards a direction where we all have these tools to be able to build the kinds of AI that we all want. Thanks.